Hi everyone, welcome to this week's video. Now, first thing you'll notice that we're trying something different this week. I don't have the pen and paper. We're going to have a look at trying to use a program called GeoGebra. I don't know whether you've seen that before. You can get it on your iPads. It can do some really cool things. I've got an application on my desktop and I'm just going to have a go at using this. Okay, so today we're going to have a look at chapter 6.6, other functions and relations. So what we've learnt so far, we're going to extend that information and explore some connections between other functions and relations. So what does that mean? Well, to start with, we're looking at maximal domains, or implied domain of a function. Now we've had a look at hyperbolas, truncus, semicircles and square root functions, and we're going to apply these maximum domains to other functions which we are not familiar with. Okay, to start with, a bit of a refresher. So we've got y equals x squared. What's the maximum domain for y equals x squared? Well, if you think about it, we've got, set of axes. Here's our x squared graph. Alright, it goes this way to negative infinity, and then it goes this way to positive infinity. Okay, really there's no spot for x squared where x doesn't exist. So x is between those 2 points. Okay, doesn't touch those 2 points, that's why we have less than signs and not less than or equal to signs. So negative infinity to positive infinity we can say as x is part of the real. Okay. I'll just get rid of that. Okay, so x squared is real. Okay, mind my dodgy handwriting on this program. I need to get a graphics pad, I think, if this works. So I'm just trialing out. Although my handwriting's not that good anyway, so it won't really matter. Okay, next one, y equals 1 on x, so this is our hyperbola. So what does that look like? I'll do it on the side this time. Okay, hyperbola, we're not moving it left or right or up and down. Okay, looks something like that. So what values of x do we have? Well, this way, again, we go to negative infinity. Okay, this way we go to positive infinity. Okay, but what happens in the middle? We've got a asymptote. Okay, so up in the middle we've got a asymptote, so it doesn't exist at 0. So 1 on x we can say is all real numbers. When my pen decides to work, okay, all real numbers. Now excluding, and that squiggly bracket, 0. So we don't want to include 0. Okay, because it doesn't exist on that point. Now for x squared, it'll be something very similar to that one, obviously. So we've got, oh, horrible, no. Okay, just a few technical difficulties. Okay, 1 over x squared. Okay, and we've got the function that looks like this. So this is our truncus. Okay, so what values does x exist? Well, we've got negative infinity, okay, going this way. we've got positive infinity going this way. And in the middle we have the same situation, we don't have an existing value at 0. So we can say that's the same as that one, and it's also the same for this one as well, provided we don't move it left or right. Okay, so it exists everywhere except for 0. Now our square root x function, okay, which is the last one we had a look at last week. Okay, and square root function starts from 0 and goes up like that somewhere. Okay, so what values of the square root function exist? Well, that's from 0 all the way up to positive infinity. Okay, so this one we can say is all positive real numbers, including 0. Okay, so that's just a bit of a summary of our maximum domains from last week. Okay, so we can start making a bit of a summary now. So we've got the maximum domain of any function must exclude two situations. Any value of x which the denominator would become 0. Okay, and we saw that here. Okay, if we have a denominator of 0, it doesn't exist. Any value of x which would create a negative number or an expression under a square root sign, and that was this part here. Okay, so we had to have all positive numbers or 0. Okay, so two situations. Denominator becomes 0, or if we get a negative number in the expression. Okay, going down, hence to obtain maximum domains, the following conditions would have to be satisfied. So first thing, we've got y equals g of x over f of x. Okay, as an example, so y equals g of x over f of x. Okay, that might be, g of x could be x squared. Okay, and f of x might be x take 1. Just as an example, so we've got two functions, one on top of the other. Now, it's similar to this one, because we've got 1 over x, we've got a situation where we've got something over x. So we have to say f of x can't be 0. Okay, that's saying that any x value for which the denominator would become 0. So we say our domain will be basically all real numbers, except when we have a denominator of 0. So when does f of x equal 0? Okay, well, just solving that, we get x equals 1. So when x equals 1, we have a situation where the denominator is 0, so f of x, or our function, doesn't exist at 1. So it'll be all real numbers except for 1. Okay, so that's that first example. Second one is y equals the square root of f of x. Now if you look at this part here, any value of x which would create a negative number or an expression under a square root sign. So that might be talking about let's say y equals f of x, and that might be x and my computer is lagging now. It's not too happy. X take 2. Okay, sorry about the technical difficulties, where I've scrapped that program, it's not working. I'm going to try something else. Okay, so just kicking off where we were up to before. We've got three situations: y equals g of x over f of x. Okay, and we had a look at that when the denominator doesn't equal 0. Okay, next one didn't get to finish off. Let's do that now. Okay, so I've got the situation square root of f of x. Now we might say that equals y equals the square root of f of x, and that might be x take 2. Okay, f of x in this case is going to be x take 2. Our y is the square root of f of x. So kind of got a function inside a function almost. Okay, so as we said before, our f of x has to be greater than 0, greater than or equal to 0 for it to be defined. Okay, so all positive numbers and equal to 0. So we can say it's defined when x take 2 is greater than or equal to 0. So in this case, x is going to be greater than or equal to positive 2 when we add 2 to that side. So just solving for that. Okay, so that's our second situation. Our third situation is a combination of the two. So we've got y equals g of x over the square root of f of x. So a bit of a complicated thing. So let's say we've got y equals g of x. Okay, I'm going to use our x squared example. Okay, x squared over the square root of x take 2. So we've got two situations. First one is f of x, which is x take 2. So x take 2 has to be greater than or equal to 0. So x has to be greater than 2. We also have the situation where the bottom line, our denominator, from our second example, has to be not equal to 0. So we have the situation where okay, x is greater than 2 and x can't be equal to 0. Well, that's already been defined. Okay, x not equal to 0 is already defined by the second bit of information. X has to be greater than 2. Okay, that's a 2 by the way. So, alright, if we've got x greater than 2, well, automatically we don't have 0 anyway, so that is our maximal domain. Okay, that's kind of contained in that anyway, and that's by the square root function. Okay, so just a bit of a summary there. Okay, so numerators can be 0. For example, for the first one, g of x over f of x, well, if g of a, or whatever it is equal to 0, then we get the example where it is defined. Okay, so just as a bit of an example, we've got okay, g of x over f of x. Now let's say g of x is x take 2, and f of x we might say is x take 5. Okay, denominator can't be 0. Okay, so can't be 5. But the top one, let's say at x equals 2. So at that point, at x equals 2, we have 2 take 2 over 2 take 5. Okay, 2 take 2 is 0, over 2 take 5 is minus 3. Okay, that's just 0. So what it's saying is the top numerator doesn't matter if we get a 0. Okay, it's just the denominator, which is the bottom part. So that is the important part. When does that equal 0? Okay, we can't have it equal to 0. Okay, so if g of a equals 0, f of a equals 2, for example, the value is equal to 0, which is defined, as I just had a look at there. Okay, at a value of x for which its denominator would be 0, a function will be discontinuous and its graph will have a vertical asymptote, as we saw from the hyperbola, or the truncus. Okay, hyperbola. The hyperbola, okay, you've got a asymptote at 0. Okay, it's discontinuous because basically meaning we've got a point where it doesn't exist. Okay, we've got an asymptote, so it's discontinuous. Same with the truncus, we'll have a point where it doesn't exist. So in summary, the maximum domain of f of x plus or minus g of x is d of f and d of g, the domain of f and the domain of g, respectively. So the maximum domain of two functions, f plus another one, is going to be both of those domains where it intersects. Okay, so let's get straight into an example. Okay, we'll take the first one. And it's asking, identify the maximum domains of the rational functions. Okay, maximum domain, x squared take 9. Okay, we know from the first situation here, okay, we've got something over something, f of x can't be equal to 0. Which is our denominator. So the denominator can't be equal to 0, so it's going to be all values except for that point. So x squared take 9, plus 9 on that side, you'll have x squared equals 9. Square root of that, so x is equal to plus or minus 3. So it's defined for all points except for those 2 points. So domain is going to be all points except for plus or minus 3. And you can check that. What happens at positive 3, 3 squared take 9 equals 0, so we don't have that point. At minus 3 times minus 3 is 9, 9 take 9 is 0, so that's not defined there either. So all points except for those 2 points is what we say. Our next part is this one. Okay, we've got a function on top of a function. Now it doesn't matter about the top part if that's 0, it is defined. It's just our bottom part. Now x squared plus 9 . So when does that equal 0? Similar to the last case, except now we've got a plus, so take away 9. Now we get the situation where x squared equals minus 9. We can't take the square root because we've got a negative number here, so there's no solution. So what that means, if we have no solution for that solving for x here, means that it's going to be defined everywhere. And what that means is we don't have a situation where the denominator is 0, and that's because we've got x squared plus 9. So all negative numbers are going to be, when we square it, will be positive, and a positive plus a positive, we're not going to get any negative numbers, we're not going to get 0. Okay, so it just means that we're going to have all real numbers for our domain. And the last example, one over the square root of x cubed take 8. We just look at the square root of x cubed take 8. Okay, when is that denominator equal to 0? Alright, square root, so square it. Square 0 squared is 0. X cubed take 8 equals 0. Plus 8. Cube root it. We get x equals 2. So, x equals 2. 2 cubed is 8. Take 8 is 0. Square root of 0 is 0. We get 1 divided by 0. So that's one point where it doesn't exist. Just got to check the second part. We've got a square root of x cubed take 8. Now we know that we can't get the square root of a negative number. So if we we need to find the values for which x is greater than 0, or greater than or equal to 0. So x cubed take 8, well, it'll be x cubed has to be greater than or equal to 2. So 8, that should be 8. So x has to be greater than or equal to 2. So we get two situations, x equals 2 and x is greater than or equal to 2. Well, we can just summarize by just saying this point here. Okay, because it's greater than or equal to 2. So we can say our domain is just going to be all points for which x is greater than or equal to 2. And that's it. Okay, you can have a look at the solutions there. For the first part, I did it something different. So they've done the a squared minus b squared, a plus b, a minus b. You can do it that way if you want. So there is no real solution for part B. So as the denominator is the sum of two squares, it can never be 0. Denominator can not be 0 for both numerator and denominator. Alright, we said all that. Actually, sorry, let's go back. Can't be equal to 2, because we said that here. Can't be equal to 2. Sorry. So it should be just greater than 2, because at the point 2, as I said, 2 cubed is 8, 8 take 8 is 0, square root of 0 is 0, 1 divided by 0 doesn't exist, so it's all values greater than 0. Greater than 2, sorry. Okay, so that's just a summary of applying what we know for maximum domains. Looking at the case where denominator becomes 0 or the square root function is negative or expression. Yeah. Okay, so next video I'm going to have a look at inverse functions. So I'll leave that here for now, and let's hope we don't have technical difficulties next time. Thanks.